So we're looking at describing data, in particular categorical variables. So categorical, sometimes called a qualitative variable. So we're just taking something and we're grouping it in some way. We're stating a quality of something. So one example of a categorical variable could be color, could be a color of an object like a car, it could be hair color, it could be eye color. There's tons of other categorical variables we use out there. For example, my social security number is really just another name for me. That is a quality of me. It's not really a number. Zip codes. Those are not really numbers. It doesn't make sense to add, subtract, multiply, or divide zip codes. They're just another name for a place. So anytime we're naming things, putting things in groups, categories, or stating a quality, then we have something that's not numerical. It's categorical or qualitative. Like in college, you could be a freshman or a junior or a sophomore or a senior. That's a quality of your state in college. So what can we do with categorical variables? Well, the biggest thing we can do with categorical variables is we can count. So in this case, again, it's a little different kind of variable, not like an algebra where a variable represents a number like 1 or 1.5 or 2 or pi. In this case, my color could be red or green or purple or any other named color I might know of. In this case, I have a select few colors, and I could count any one of them. For example, we could count the purple. And looking at the list, I see 1, 2, 3, 4, 5, 6, 7 purples, and I could have missed one. So usually we want a computer to count these, but when I count the purple, I get that there's 7 of them. And another word for count in statistics is frequency. How often does it occur? Typically the frequency we're going to give the letter X. Now I could count everything in here, which is usually the same as the sample size. And so counting all of these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I get a total count of 23, and sample size you usually give the letter N. I could also say 7 out of 23 are purple here, and that's what we call relative frequency. Relative frequency here would be 7 out of 23, which we could turn into a percent if we like with a calculator. But it's just whatever the count is for that object, for that value of the variable divided by how many total elements there are in that particular set. And those are the main statistics we work with. Another statistic we work with, and again, the idea of a statistic is a calculation you do on data. Counting is a calculation. Relative frequency, the division, that's a calculation. We could ask what the mode is, and the mode is the most frequently occurring. And so we'd have to look at the counts for each one to see which one occurs most. If there is one that occurs most, then we say the mode is purple or the mode is green. And so that's just the highest frequency that we see in the data set. Graphically, we don't want to look at a list of colors like this, especially if it's long. This is only 23, and that's more than long enough to make it like not that useful to look at. We're going to look at graphs of them, and there's basically 2 kinds of graphs we're going to make, and both graphs are based on what we call a frequency table, which is a table that has all the frequencies. So when we make graphs, we're first going to make frequency tables, listing all the frequencies. And then based on that frequency table, we can either turn it into a bar or column chart, or we can make a pie chart out of it. There is a special type of bar chart called a Pareto chart that we'll make too. That's where you list them in order from the most frequently occurring down. So that's a special type, Pareto, and that just has descending frequencies. Let's make some. So most data sets, it doesn't make any sense to do these by hand. You should use some software to do it, and spreadsheets do a great job. So I'm gonna grab these in a spreadsheet, and the video has a link to the spreadsheet if you wanna give some of this a try. First thing you need to know in a data set is what's the sample size. And so we're gonna have the computer count them for us. So my sample size, to do that, I'm gonna have it count. Now, if I type equals and then start typing count, I can see there's a bunch of different commands that have the word count in them. Count counts numerical values. These definitely aren't numerical. Count A counts the number of values in the data set, and here it doesn't specify numerical, so it could be a value like purple or green or blue. So I want count A, and then I just grab my values. Now I'm not gonna grab the title because I don't want it to count that. It's gonna count anything. Now, if I go too far, notice it still says here the count is 23 because these cells are empty. So important, when you use count A, grab the data, but not the title. So this says my sample size is N, 23. So I'm just gonna put a little N there, reminding me. Next thing I wanna make here is a frequency table where it counts all of them for me. So a frequency table, you should have two columns. One column is for the values in your data set, and the other column is the frequency or count for each one. And so my values looking at this are purple. Maybe I should spell purple. There we go. Green. And again, I'm looking for them by hand. So a better way to do it is have the computer do it for you. And it turns out there is a way to do that. I'm just going to type these for fun. Green, we got blue next. I could alphabetize them, that might help. We got a red, we got a green, I got green, we got orange. Did I get them all? So again, I got a lot of places I could make errors here. I want to let the computer do as much orange as possible for me. So just off to the side, I'm going to check the unique values. Unique. And there is a function called unique. And it says unique rows in a provided data source range. So if I select that function and then I select, again, I don't need the title, but I select all of those, I close it, it will then list out for me everything in there. And it found a purple and then a green and then a blue and then a red and then an orange, which is what I found too. Okay? But it's a really good idea to have the computer do it for you. And there's usually a function or a combination of functions that do almost anything you want. So that was a nice one. To get the frequency, I might sort them. Now, let's just add a new column here for fun because I want to explain something about sorting in a spreadsheet. So we're going to insert a column to the left, and these are favorite colors voted on by students in my class. So I'm going to put a student column in here. And instead of naming my students, I'm going to say I have student number 1 and student number 2 and so on. And in my grade book, I can tell who student number 1 is and student number 2 and who student number 23 is. When I sort these, I always want student number 4 to be purple and student number 6 to be blue because that's what they picked. And so if I sorted the colors separately, it's going to mix up who picked which color. So anytime you have related data, no matter how many columns are related, highlight all of the columns, including the title, data, sort range, do the advanced sort, and say my data has a header row, then you can pick whichever column you want to sort by, and you can add subsorts to that. So I want to sort by colors, and yeah, sure, let's go A to Z. All right, so here I can see the blues, the greens, the oranges, the purples, and the reds. And so I can just look at it and say, okay, it looks like there are 6 blues. They're in a different order. There are how many greens? 4 greens. Again, lots of room for human error I'm introducing here, which I want to avoid. I'll show you how to avoid it. Orange is 2. purple is 7, and red looks like 4. So I could have messed up any of those, maybe more than one. To double check you have the right number of numbers there, you should always do a total. Total on a spreadsheet is a sum. So equals sum, and then highlight the numbers. And it says the sum is 23. So did I do this right? That's evidence that I did it right. But again, I could have maybe overcounted the blues and undercounted the greens. So a better way to get those frequencies is to have the spreadsheet get them for you. And there is a function called count if. So we only count something if it meets a certain criteria. So let's try that. So I want to count anything in this range of colors here in my data set. And then comma comes the condition. So I could do the condition in a couple of ways. I could do parentheses, quote, equals, and then what am I looking for? In this case, I'm looking for purple. And it says, hey, I see 7 purples. Now, this is not case sensitive, by the way. Notice I typed lowercase purple and it found uppercase purple. So the check here is not case sensitive, which is good and bad. So that's one way to do it. Another way to do it, still with count if. So count if is you have to select the range. Where are you going to look? So I want to look in here. And since I already have next to this the color that I'm looking for, the condition just be to match whatever's in that cell right there. So the count if is going to look in the cells that go from B2 to B24. And if there's a match with whatever's in cell C5 in this case, it's going to count it. And so it's saying it counts 4 greens. So that's the ideal way to do this. I'm going to go back and redo the purple. Instead of typing it equals purple, I would just comma and then click on the value purple next to me. And since I have all the values listed here, I can just fill that formula down. Okay, now I should have it right. So let's see. Oh, I got 21. So something went wrong. What went wrong? Oh, yeah. Okay, so what went wrong? When I filled the formula down, I started looking in B2 to B24, and I was in cell C4 for the check. When I come down, I want to be in C5 for the check, but notice it shifted the cells I'm looking in down. So every time I copied the formula down, it shifted the cells down. So I need to tell it here, the data is always from row 2, so put a $sign in front of the 2, to row 24, put a $sign in front of the 24. And the $sign says, as the computer reads through this, it says, okay, go to column B, always start in row 2, go to column B, always start in row 24 when I'm looking for the data. I don't worry about putting a $sign in front of the B to say always look in column B, because I'm only filling this down. As I fill down, it wants to change the row numbers. If I was moving the formula left or right, then I would put a $sign in front to fix the column I want to look in. But in this case, I only need to fix the row numbers. Now, if I fill it down, it should behave correctly. Okay, and there are the proper numbers I want, and they add up to the 23 there. So that's a frequency table. Based on the frequency table, we can make a chart, and the 2 types of charts you would make are either a column chart, and it tried to graph values, so it's a little confused about what I'm doing. Let's see, use row 3 as headers. Yes, that is correct, because the word value represented either purple, green, blue, red, or orange, and then there were the counts. So that's my graph for that one right there. It's just missing relevant titles. So sometimes you have to adjust where the X values are from. My X is the values column, which is purple, green, blue, red, or orange. That's the X-axis. And the Y values are the counts for each of those. And so that's here. You should always customize and add some titles. So for my chart title, this would be something like students' favorite colors. And then for the horizontal axis, I think it's pretty obvious what they are, but I'm just going to put colors there to put a title in there. And then the vertical axis, now what did I make? I made a frequency table. So for the vertical axis, I could say these are the frequencies. And that's great. It's true. These, the frequency of purple was 7, but that's a statistical term. It's valid. It's great. But thinking about audiences, like if my mom looks at this or I publish it in some periodical, frequency is not going to mean a lot to most people, and they might prefer count as a title for that column. Oh, purple had a count of 7. Okay, what are you counting? What purple? How many purple what? And then a better title for that in this case would be something like number of students, because that's what I'm counting, the number of students that picked purple. Oh, okay. So it is a frequency, it is a count. It's also, in this case, the number of students. So try to choose good column names, and that is often a challenge, or good names for the things in your chart. All right, so that's one thing we can make there. Another thing we could make besides a column chart or a bar chart would be a pie chart. And if we switch to pie, it then colors things. Now notice it's not the colors I would pick. It just kind of randomly assigned colors there. So I could always click on one of these. That takes me to customize that slice, and I can pick a better color. So these are customizable quite a bit. So I'm just going to redo some of these, make it a little more attractive and more color correct. Glad I don't have more colors. That is definitely orange, but we want the color orange. There we go. That's a great graph. Now notice that the display here, it chose to display, instead of the count, the relative frequency as a percent, right? So for the orange, what was that one? Orange was 2 out of 23. So 2 out of 23 apparently is 8.7%. It automatically did that work for us. We're going to calculate that in the spreadsheet next. Notice this is missing relevant titles. So I should definitely go and add a title, like what am I graphing here? So again, students' favorite colors would be a good idea. And it's got a built-in legend, which is awesome. So the spreadsheet calculated for me those relative frequencies. I'm just going to add that here. So I'm going to add a new column. And let's see, we can get rid of the word count there and just call it frequency. We're going to make a column called relative frequency. And the relative frequency is equal to the count for that particular item divided by the sample size. I'm just going to type 23 so I don't have to worry about $signs in the formula. And Google wants to fill it down forever. I just want to fill it down a few times. And then we have to decide how we want to display that. So dividing by 23 leads to these messy decimals. So typically I'm going to round something like that. And usually we go to one more decimal place than the data. These data are whole numbers. So one option would be to taking it down to a single decimal place. Given that these are complicated decimals like 7 out of 23, I think I might go one more decimal place in this case. So if I do it that way right there, and I were to make a graph, so I want to graph the values versus the relative frequencies. To graph things that are not next to each other, highlight one, then let go of the mouse, hold Control on the keyboard, and then highlight the other one. And then it selects disjoint things. And then as long as those are the same length, I can make a chart out of them. And it's picking the bar chart for me, the column chart. And this is really almost identical to the one I created. The only difference is this scale right here. And so I'm just going to make an edit on this. For the titles, this is still the same data, just displayed a different way. Students' favorite colors. And the bottom is still colors. That's pretty straightforward. We'll skip it this time. But the vertical axis means something different. That is not number of students, and it's not percent of students either, because I didn't make these percentages. I could say it's fraction of students. That would work. Typically in statistics, when we do a calculation that's a fraction, instead of calling it fraction, we call it a proportion. So often you'll see this labeled as proportion of students. So that would be a good label for that one right there. If I wanted them to be percentages instead, I would simply just highlight those numbers and say, hey, make them percents instead. And the spreadsheet, the table automatically, or the graph automatically updates. So relative frequency is a fraction. That fraction can be displayed as a decimal, a fraction, or a percent. We have a couple different options on that. All right, so quick summary of what we did here. So I described again the idea that we can count individuals, that the sample size is important, that the individual count divided by the sample size is what we call relative frequency. The most frequently occurring item is the mode, and we can make two kinds of charts, a bar chart, which is also called a column chart sometimes, depending on the direction, and a special version of a bar chart is a Pareto chart, where the frequencies go in descending order. Now, I don't believe Google has a way to do that automatically, so I'm just going to copy these. Now, I'm copying formulas here. I just want to paste them in as values, so I'm going to do an edit, paste special. I only want the values, not the formulas, because I want to be able to sort them more easily. So now I have those. I'm going to go to my format or data, sort advanced, has a header, and I want to sort by frequency this time, and I want to go large to small. And once I resort them that way and make a chart out of them, that type of bar chart is called a Pareto chart, where we list the values in decreasing order based on their frequency. So this is a Pareto chart for the students' favorite colors. All right, summarize some of those formulas that we went over there. So important formulas on a spreadsheet. If I want to count all categorical values in a data set, or for a variable, I should say, it's more. Then that is usually the sample size n, and we're going to do the count A command, and then we highlight the data itself, data, but when you highlight the data, don't get the title too. So don't grab title also, because we don't want to count that. That'll give you one extra thing in your list. So that was important. To make a frequency table, we needed to count individual values. So to count a specific value, we call that X for that value, like how many times did purple happen? That we used count if. Count if, and count if wants to know what is your data, and then what is the condition you're going to count on. So an example of that would be earlier I did something like count if the data in cell A2 through A24, something equaled the word purple. And there's all different kinds of conditions you can come up with. So you can, if you want, you can look up other conditions, but I just want to do the simple version of a condition there. So that was an important one for us. Also, sometimes we want to know if we have all those counts correct. So if we want to add up all the frequencies, that should be the sample size. Then we're going to use the sum command, and we're going to sum wherever our frequencies are. So again, example of that in my spreadsheet was when I was double checking that I had things in the way here. When I wanted to double check that my frequencies really added to 23 there, I did a sum on those frequency values, and it confirmed that I got the sample size, which used the count A command. If you sum the frequencies, you should always get 100% or 1, depending on how you have them displayed. So here they're percentages, so they should add to 100% all of the data. If instead of percents, I had them as decimals, then they should add up to 1. So that's another important idea. The sum of the frequencies and 1 is 100%. And one other formula I used to double check I had all the correct values for the variable was I used the unique function. And it just lists the individual unique values. In the data. All right, so that is the basic statistics we calculate for categorical data, how we use a spreadsheet to analyze categorical data a bit and make some graphs to help get a handle on what is going on with this particular categorical variable. Thanks for playing along.